Okay, we're going to be looking at some trig problems. Let's see. This is section 3.4. Oh, that's not what I meant to do. Got to share it with you. All right, so here we're looking at finding trig functions based on, well, inverses for trig functions. And a few other things here and there using our calculators, solving for angles. So let's delve in. All right, let's see what's going on. So we've got these first ones, we're just trying to determine these inverse functions without a calculator. So we're not using a calculator here. So we just have to remember, these are actually all cosine, but recall that the range for cosine inverse is similar to that as cotangent inverse and secant inverse. So, oh, and it's kind of cool. This question actually tells you that. In general, cosine inverse, cotangent inverse, and secant inverse, their solutions are going to be on the top half. So between 0 and pi. And this is because, again, in order to make it a function, we've got to make sure that there's only one solution, one answer. So this first one wants to know cosine inverse of square root of 3 over 2. So in other words, it's asking the cosine of what angle is equal to the square root of 3 over 2. Now, again, there's a lot of solutions when you look at it this way, but cosine inverse is only between 0 and pi. So where between 0 and pi does cosine have, is cosine square root of 3 over 2. And so we know that happens at this kind of shorter triangle here. And that is our, does this one want degrees or radians? This one wants radians, so that happens at pi over 6. Let's keep looking at these others while we've got the picture up here. So the second one says negative root 3 over 2. So again, it's asking what angle between 0 and pi has a cosine of negative root 3 over 2. So remember, cosine is our initial, like our x value or horizontal value. So this is going to be here. And so we just need to figure out how did we get all the way to this angle. We know that this part's going to be pi over 6, so that must mean the entire angle is 5 pi over 6. You see how that's just one short of the full pi, so that's in the second quadrant. So that one's going to be 5 pi over 6. And then the last one wants to know about root 2 over 2, and that we know is our perfect middle guy, our 45, 45, 90 triangle. So that's pi over 4. All right. So we've got those guys. I'm just going to push. Oh, I didn't realize I was going to do that, but never mind. We'll just put the answers in. Okay, so that's going to give me pi over 6. This one is going to be negative pi over 6. And this last one is going to be pi over 4. Oh, look, this one's tangent. Oh, this is the second question. Okay, whatever. All right, let's look at tangent inverse. So again, thinking about what our answers can possibly be, and this one tells you, usually you're not just told that, but again, kind of thinking about putting our triangle here on the standard axes. Sine inverse, tangent inverse, and cosecant inverse are going to be found between negative pi over 2 and pi over 2. So their answers are all going to be coming from over here, okay? So the first one wants to know about tangent inverse of 1. So again, it's asking where is tangent equal to 1, but only between negative pi over 2 and pi over 2. Now, because these are all done without a calculator, our possibilities essentially are going to be, let's see, we've got a root 2 over 2 point for sine and cosine. We've got a root 3 over 2, 1/2, and we've got a 1/2 root 3 over 2. All right, so this we know occurs at the pi over 4s, this occurs at the pi over 6s, and this occurs at the pi over 3s. So for tangent to be equal to 1, we know that tangent is sine divided by cosine, so it must be where the two are the same, and that would happen here. So the answer here must be this 45, 45, 90, so pi over 4 here. So we know that this one's going to be pi over 4. Now this next one is negative root 3 over 3. So it's going to be one of these 2 points. We just have to figure out which one of these has sine over cosine being equal to that. So we could actually just look at those real quick. Let's just check it out. If I did the tangent for pi over 6, that would be sine over cosine, which would be 1 over root 3. And so when you rationalize that, you would get root 3 over 3. So it turns out that this one is going to be your pi over 6, but notice it's negative, which means we need to be down here in the 4th quadrant. And what's kind of nice is because of the way these answers have to be, you don't have to try to figure out what that is to get over to the 4th quadrant. You can just say, oh, that's negative pi over 6. So that's actually kind of nice in this sense. And so now I was going to go ahead and find both the possible tangents, but we got lucky on the first one. So let's check out what the tangent of pi over 3 is. And notice that would be sine over cosine, which is root 3. So this last one is the pi over 3, but because of the negative, it means we want to go down to it. So our triangle is actually down like this. And again, we don't have to go all the way around to get to it. We can just say it's negative pi over 3. So again, that's kind of nice. With cosine inverse, cotangent inverse, and secant inverse, you have to figure out what it is in the second quadrant. All right, let's look at this next one. So this one wants me to use my calculator. And notice that it's telling us to make sure we're in radians. So again, this is asking the cosine of what angle would be equal to 0.32. That's not one that we know. You see, we know halves and root 2 over 2s and root 3 over 2s. We know zeros and ones. We don't know this one. So just make sure that you're comfortable with your calculator. Here's my calculator. Some calculators you have to put, well, first off, make sure you're in radians. So looking at mine, it says degrees here. So I'm just going to switch that over to radians. And then some you put the 0.32, then you push the cosine inverse. Some you would do cosine inverse, then 0.32. But also you need to make sure that you're in inverses. So I'm going to pick cosine, which is not actually what I want. I was wondering if, let's see, maybe this one won't do it. Oh, second. So second cosine inverse. And then I'm going to just type in 0.0. Look how it's coming up right there. So in this one, I should have practiced it first. In this one, I believe you're going to do the 0.32, then do the cosine inverse. There we go. So you see it showing up there what it just did. So in this calculator, the computer's calculator, you have to push the 0.32 first, then do cosine inverse. So we get about 1.245, and I can't recall how it wanted the answer. It does say 3 decimal places. So we'll do 1.245. Yay, we got it. All right, so now here we're going to be using what we were just doing to actually find values in a right triangle. So it says for the right triangle below, find the measure of the angle. This isn't drawn perfectly, but that is a little arrow pointing at that bottom right angle there. So, and it does say it's not drawn to scale, so keep that in mind. So that's a 10, that's a 4. This is the one we're looking for. So what we want to do is figure out which trig function we should use in order to find that angle. Now, actually, you could use any of them if you finish this right triangle. We know we can use the Pythagorean theorem to find the missing piece. But in general, let's just see. This would be the opposite of the angle. And this would be the adjacent of the angle. So we just want to say which trig function would use opposite and adjacent. And that would be tangent. So the tangent of this would be equal to 4/10. In other words, 2/5. So what you're going to do with your calculator is you're going to put in tangent inverse of 2/5. Okay, so we're going to be doing tangent inverse of 2/5. It'd be nice if I could just put it in like that. I'm going to try it just to see what happens. I like doing things like that. So if I tried to put in, so notice the little trig box opened up. I was just curious. Okay, so do notice at the end, it does want it in degrees. It didn't specify that in the question itself, but it says it down here. So we need to know what the tangent inverse of 2/5 is. So we'll pull up our little calculator. I'm going to put in 2/5. Oh, I guess I didn't need to do that. And then we're just going to do second tangent of that. And it looks like 0.38. And this one does not specify decimals. Oh, you guys, I was not in degrees. Move that over to degrees first. Oh, not gradients. Okay, so 0.4 second tangent. Okay, 21.8. I'm just going to try 21.8, see what happens. Again, this one didn't specify the number of decimals, so we were good there. Okay. So this is back to using our inverses, and just kind of, it's really about practicing with the types of answers you'll get here. So if we look at this one, we can just evaluate the inside first. So the sine of pi over 6, we know to be 1/2. And so then it wants to know the cosine inverse of 1/2. So that means where on the top half, so between 0 and pi, is cosine 1/2. And we know that that happens at our tall triangle. And that is going to be, it doesn't look like it specifies which way to write our answer. Oh, well, this is radians, though, so give them back radians. So that would be pi over 3. And then on this second one, it has the sine of 4 pi over 3. So first we got to figure that out. So the sine of 4 pi over 3. We know that the over 3's have a sine of √3/2. So now we just got to figure out what quadrant he's in so we know which sign to pick. So 4 pi over 3 is just a little bigger than a pi, right? So that means he's going to be down here in the third quadrant, and sine and cosine are both negative in the third quadrant. So this is actually going to be a negative √3/2. So then it's asking cosine inverse of that. So now here's the kicker again. These inverse functions, cosine inverse, cotangent inverse, and secant inverse have to be between 0 and pi, like we have in our picture over here. So if I want to know where cosine is negative √3/2, I'm going to want the pi over 6 that falls in the second quadrant. So I just need to figure out how to get there. And that's just 1 shy of pi. So that would be 5 pi over 6. All right, let's see. This is well, these up here, notice, were things on the unit circle that we know and love. This one is now busting out with a 6 over 13. That's not something we know from the unit circle. So what we'll do is draw a triangle. So let's look at solving this with a triangle. And notice that the tangent is positive here. And, oh, well, it's tangent inverse. So tangent inverse has to be between negative pi over 2 and pi over 2. So because it's positive, I'm going to draw my triangle here in the first quadrant. I'm going to label my angle. Let's just call him theta. And so by saying that tangent inverse, or by asking tangent inverse of 613, we're asking the tangent of what angle is equal to 6 over 13. Now remember, these trig functions are ratios, right? And for tangent, it's the ratio of opposite to adjacent. So what we can do is in our triangle is say, oh, so the opposite must be a 6, or not, it must be in the ratio of 6 to 13. That doesn't mean it is 6 and 13, but there's our ratio. So looking at that, it's then asking us, it wants to know what is the sine of that angle, right? Because that's our theta. Well, sine is in the ratio of opposite to hypotenuse, except we don't have the hypotenuse written here. So let's find the hypotenuse first, and then we'll be able to answer the question. So this is just going to satisfy our Pythagorean theorem. I'm going to call him H for hypothesis. So we'll know that 6 squared plus 13 squared has to equal H squared. So 6 times 6 is 36. That's 169. 9 and 6 is 15. Carry the 1. Looks like 205. It does say exact value. That means do not put this in your calculator. So H is going to be the square root of 205, whatever that may be. So now I can come in and say, okay, so then the sine is going to be equal to, so the sine of the angle, whatever the angle is. Notice we're not actually finding the angle, but it asks about the sine. So sine is the ratio of opposite to hypotenuse. So 6 over the square root of 205. And I'm guessing we can put that in without rationalizing. So let's just try that. Yep, it was fine with that. Okay. So this you're going to do very similar to that. It just happens to have an R in it instead. But you'll do the same exact thing. So set up your triangle. Sine is the ratio of opposite to hypotenuse. So you know that the opposite is an R. The hypotenuse is a 4. So just use the Pythagorean theorem to find that adjacent side and put it in there. It will have an R in your answer. This is also similar. This is actually secant. So secant of secant inverse will just be the square root of 21 as long as it's in the right place. But if you wanted to, instead of trying to use kind of the inverse shortcuts here, you could still just solve this. So this inside piece is saying secant inverse. Remember, that's just another way of writing that. So whatever this is some angle. So in other words, the secant of the angle is equal to root 21. Now remember, secant, well, secant goes with cosine. We know that the cosine of the angle would be the ratio of adjacent to hypotenuse. So that means the secant must be the ratio of hypotenuse to adjacent. So you can come down and say, okay, this is secant, which goes with cosine. It's positive, so I must be here in that first quadrant. And I know that the hypotenuse is the root of 21 and that the adjacent is 1. And again, these are in ratio. So now you could use the Pythagorean theorem to find that missing side. Oh, except we don't have to do that because it's asking for secant, which again, we know is hypotenuse to adjacent. So notice if I then was asking about the secant of theta, I would get root 21 over 1. You see how they're inverses. So essentially they undo each other. Now, every once in a while, there's, you can't just do that, but in this case, we can. So this is cosine of arc cotangent. So again, just think about it the same way. So this is telling me that the cotangent of some angle is 19 to 21. Now, cotangent is the reciprocal of tangent. So if tangent is the ratio of opposite to adjacent, this must be the ratio of adjacent to opposite. Again, notice it's positive, which for inverses then tells me first quadrant. So the adjacent is 19, the opposite is 21. So this is going to be the square root of 19 squared plus 21 squared using the Pythagorean theorem. I don't know what that is. So then this is our angle. So then they're saying, oh, so what's the cosine of that? So the cosine for our angle, cosine is the ratio of adjacent to hypotenuse. And it would look like that. So let's actually put that in, see what happens. So this would be the ratio of adjacent. Oops, way too many. To hypotenuse, which would be 19 squared, the square root of 19 squared plus 21 squared when we use the Pythagorean theorem. And it was fine with that. Hey, I like it when it does that. All right, so that is using inverse trig functions with triangles as opposed to the actual unit circle. Dun, 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 dun. Oh, whoops. That's me, that's me.